7b, percent continued. So previously we got introduced to percent, and we basically said that you can deal with any percent problem by doing is over of is equal to percent over 100. So now what I'm going to do is I'm going to modify this slightly. It still is over of is equal to percent over 100, but we're going to deal with percent markup or percent discount, basically comparing the amount that something changes to the original value. So we're going to modify this, and instead of saying is over of is equal to percent 100, I'm going to say amount of change, amount AMT of change, CHG, over original is equal to percent over 100. Now, if you look at these, see, you're still saying is over of is equal to percent over 100. Of the original amount is what it's of. If we started with 22, of 22. If we started with 908, of 908. The amount of change is the change is of the original amount, percent over 100. So we're just going to modify a little bit and use that. So now we're going to bring this into discounts or markup. If you're not familiar with the term markup, it's used in retail when you purchase something for a certain price and then you charge a higher price for it. That change is called the markup. So if I buy something for $1 and sell it for $2, then I marked it up by $1. Or to make it a little bit clearer, if I buy something for $2 and sell it for $3, the difference between what I buy it for and what I sell it for, that other dollar, is the markup. So that's markup. Discount, we all are pretty familiar with. That's how much you save, right? How much you change, how much you take it down. If something originally sells for $100 and it's on sale for $75, then it was marked down by $25, or in that case, 25%. So let's say that you go to a store and you're looking at a shirt that was originally $49. So I'm going to call it manufacturer's suggested retail price. For those of you who aren't familiar with MSRP, manufacturer suggested retail price, $49. But you go in and they've got it on sale for $41. That's the sale price. I want to find the percent discount. That's what percentage of the original price am I saving? So if I look at this, I'm going to fill in the same spots that I did before. I'm looking for the percent discount, the question mark there. So I'm looking for that. The original price was $49. So there's my original, my of. The sale price was 41, but remember, it's not sales price, it's amount of change. How much did the price change? So 49 minus 41 gives me $8. So the amount of change is $8. I save $8 of $49, and I'm looking for the percent. So you can say 8 is what percent of 49? Back into that original question again, right? So now x is equal to, well, multiply the diagonal. 8 times 100 is 800 divided by 49. So 800 divided by 49 gives you 16.33%. So that is a 16.33% discount. Original price, difference between the original price and the sale price, or the amount of change. We wanted to find the percent discount. And sometimes you do that. You go into stores and they have the original price and then they have the sale price, and that's where you give it. And other times, if you go into a place like Kohl's, they do the opposite, that they give you the original price and then they say it's this percent off. And they do that on everything. Meaning at Kohl's, they do that on everything. So let's say we're in there and we see a pair of pants for $79. So that's the manufacturer suggested retail price, $79. But being Kohl's, everything's discounted. So they tell you it's 60% off. And we want to know, how much will we pay? So I'm writing, how much does it cost? Okay, so the same type of thing, we're going to do amount of change over original is equal to percent over 100. So we're going to look at this, and the first thing we're going to do is we're going to remember that this 60% off, that's going to give us the amount that we're taking off of the original price. That's not going to be the sale price. But we want to find out, what is 60% of $79? So X is equal to, multiply the diagonal, 60 times 79. So 60 times 79, which is 4,740, divided by what's opposite, 100, which gives you $47.40. So $47.40. That is your discount. Now I want to know how much it costs, so I'm going to start at the $79 and subtract that $47.40, which gives us $31.60. So how much does that pair of pants end up costing? $31.60. And that's discount. Let's go the opposite way. Let me disappear once again. I like to disappear and reappear. And work on markup. Oops, I didn't need to erase that, but we'll work on the same setup. So if we're dealing with markup, now the change is going up, right? We're marking it up. So let's say I'm another clothing store and I go and I buy some clothing at wholesale. Wholesale is the discounted rate that retailers purchase their products so that they can then mark them up and sell them to you and make a profit. So I go out and I buy a shirt for $12 wholesale. That's the price that I pay as the retailer. And then I go and sell that shirt for $29. And that's the retail price, right? So the wholesale, I bought it for 12, I sell it for 29. So my question is, what percent markup did I make on that sale? It started as 12 and I sold it for 29. Well, we can go back into that amount of change over original is equal to percent over 100. I'm trying to find the percent, so there's the what. The amount of change, 29 minus 12 is 17, so the price went up by $17 over the original price I paid was $12. So original price was 12, I marked it up by $17. I want to find out what percent markup. So again, 17 times 100, x is equal to 1700 divided by 12. 1700 divided by 12 is 141.6 repeating percent, or 141 2/3%. So what percent markup? Approximately 142% markup. I more than doubled my money on selling that to you. And that's how markup works. It's just an amount of change over the original value is equal to the percent over 100. Well, maybe I work my store a little differently. In this case, I bought it for 12, I sold it for 29. Well, many stores, many retailers have a set markup that they use. A very common markup for retailers is 100%. So basically they double whatever they pay for. If they pay $2 for it, they sell it to you for $4. If they pay $10, they sell it to you for $20. And that may seem like a large markup until you realize there's a lot more involved than just buying the item and then selling it to you. If you walk into a store, what else is there? Well, there's all the employees, there's electricity, there's the store itself, there's insurance, there's all these other costs that are involved. There's transportation, materials and supplies, right? Because even the cash registers, the machine, the equipment for that, the receipts that can print out of it, etc. So 100% markup seems like a lot, but that's not 100% profit. That's just the markup on that particular item. And a lot of that markup goes to covering all the other costs. So 100% markup standard in most industries. You go into some industries and markup is much higher. If you look at jewelry, for jewelry, your markup may be in like 600 or 700%. Meaning if they buy it for $10, they sell it to you for $70 or possibly even more. But that's the way it is. So that's why when you go into a jewelry store, don't pay full price. That's how they can afford to mark up. Well, they can afford to discount a product to the point that they can say 80% off or 70% off. It's because they have such high markup to begin with. On the other side of things, if you go to a new car dealer doesn't use anywhere near the markup that a standard retailer does. If you go into a car dealer and a car is listed at $20,000, they didn't buy it for 10. Okay, so they have a much smaller markup. It would not be surprising for them to have a 20 or 30% markup. But they can do that because they're selling such large ticket items that they don't need to make a huge percentage on each one, because 20% of a $10,000 car is still $2,000. So 10% of a $20,000, that's $4,000. So they don't need to make that huge markup. And that's why they don't have as much wiggle room on their prices that they charge you. You can't go in and say, $20,000 car, I'm going to get that for $15,000. No, because they probably paid more than $15,000 for that car. So those things to keep in mind. But that's dealing with percents and markup and discounts. Last thing I want to talk about dealing with percents is conversions. Conversions from decimals to percents, percents to decimals, fractions to percents, and percents to fractions. So if you want to convert a percent to a decimal, it's actually very simple. It's just a matter of dividing that percent by 100. So if you have 6.2%, that is equal to 6.2 divided by 100 is equal to 0.062 as a decimal. So percent per 100, 6.2% is just 6.2 per 100, do the division, 0.062. Now you may also notice with this that 6.2% to decimal 0.062, we just moved the decimal point 2 places to the left. So looking at that, if I have 17.8%, then I can go, oh, 1, 2, that's 0.178 as a decimal. Be careful, do not put a percent next to this. That would make it wrong. As a percent, as a decimal. And converting the other way can be just as easy. If I have 0.42 and I want to convert that to a percent, or actually to make it fit with our percent and decimal thing, if I have 0.42 and I want to convert that to a percent, I can do that by multiplying it by 100. We divided by 100 to get from a percent to a decimal. So if we multiply it by 100, we go from a decimal to a percent, which gives us 42%. And as you can see with that, to move from a decimal to a percent, we move the decimal point 2 places to the right. So if we have 1.8 as a decimal, then as a percent, we're going to move it 2 places to the right, and that's 180%. So that's converting from a decimal to a percent or a percent to a decimal. Well, what about a fraction to a percent? Well, the simplest way to convert a fraction to a percent or a percent to a fraction is to deal with decimals. If you want to convert a percent to a fraction, then start with the percent, 11.2%, convert it to a decimal, which moves that decimal point 2 places over to the left, 0.112 as a decimal. And then convert that decimal to a fraction. Right? Because it's easy to convert decimals to fractions and fractions to decimals. So, and it's easy to convert decimals to percents and percents to decimals. So we convert the percent to a decimal, and then as a fraction, that's 112 over 1,000, right? That's 112 thousandths. And then we can simplify it. I can see that they're both divisible by 4. So I get 28 over 250. And then I see that those are both divisible by 2. So I can go further and make that 14 over 125. And then I don't see that I can go any further than that. So 11.2% as a fraction is 14 125ths. If we have a fraction, 3 and 2 ninths, and we want to convert that to a percent, we can convert that to a decimal. So let me label that as being a fraction. Convert it to a decimal, which converting to a decimal, remember, all you have to do is divide, right? That's division. So it'd be 3.2 divided by 9 is 2 repeating. And then to turn it into a percent, we just move the decimal point 2 places to the right, 322.2%. So if we can convert between decimals and fractions, and we can convert between percents and decimals, then we can convert between percents and fractions just by combining the two things. And that finishes percents.